Hello dear students, hope you all are fine. In the last class, we discussed our different properties of definite integrations. Today, we discuss some problems regarding this property of definite integrations. So, let us move to the problems. So, our first problem is, that is number 1, integration -1 to 2 mod of x cube minus x dx. So, this is one type of problem that we can use our property in such problems. How we can use property? Look at this modulus function. We all know that modulus function, that means mod x is defined as that is x if x greater than equal to 0, minus of x if x less than 0. That is the definition of modulus function. So, here this mod x cube minus x, we can apply the same definition. So, mod x cube minus x can be written as mod x cube minus x can be written as, that is x cube minus x if x cube minus x greater than equal to 0, or minus of x cube minus x if x cube minus x is less than 0. So, this is the definition. Now, we have to see where it is greater than 0 and where it is less than 0. For that reason, we have to solve this one. So, let us assume this one, that is x cube minus x equal to 0. Then here what we can do? We can take common x and then x square minus 1 will be there, and that is implies x plus 1 into x minus 1, and that is equal to 0. This means x equal to 0 or x equal to minus 1 or x equal to 1. That means we can divide our interval -1 to 2 in such sub intervals, that suppose here is the interval -1 and here and 2, and here -1 is here, then I put some 0 somewhere here. That means you have one interval as -1 0 and your second interval will be 0 to 1 and your third interval will be 1 to, that is 2. That means we can divide our interval -1 to 2 in some 3 sub intervals, that is -1 to 0 is one interval, 0 to 1 is another interval, and 1 to 2 is another interval. Now, as per property number P2, what we know? P2 says that if the integration from a to b f of x dx can be subdivided as a to c, that is f of x dx plus integration of some c to b f of x dx. So, I can apply our P2 property, this property over this question, because this interval we can subdivide it as -1 to 0, 0 to 1 and 1 to 2. I can get some points in between this -1 and 2, which will give us 2 new intervals. So, that means we can write this question as integration of -1 to 2 mod of x cube minus x dx is equals to integration of -1 to 0, okay, -1 to 0. So, second one will be, that is 0 to 1, that is 0 to 1. Third one will be that is your 1 to 2. Everywhere you will have some dx. Now, question arises, which one will come here and here and here? This one. So, that we have to check which value we are getting. We are getting positive value or negative value within this interval. Suppose you are putting some minus 1 to 0 one value in between this function, what you are getting? Suppose I am putting that is x cube minus x, and I am putting some minus 1 by 2, that is minus 1 by 2 we are lying between this minus 1 and 0, that means minus 1 by 2 whole cube minus and minus 1 by 2. So, that means this will give you minus 1 by 8 plus 1 by 2, and that is what? That is some 8 and minus, and that will be plus 4, that means you are getting some 3 by 8 here. So, that means you are getting some positive value. So, you are getting positive value, that means you have to choose the positive function from here. So, that means we have in this interval x cube minus x and dx. Similarly, again you repeat the same, that is x cube minus x, and you have to choose some point from in between 0 to 1. 0 to 1 means what? You can take 1 by 2 again here. So, 1 by t cube minus 1 by 2, and that is 1 by 8 and minus 1 by 2. That means you will get some 8 here and 1 and minus 4, that means minus 3 by 8. You are getting some negative value. Once you are getting the negative value, that means you have to choose the negative function, because negative and negative will make it the positive. So, that means in this interval you must choose this one, that is x cube minus x and dx I have already written. And finally, again 1 to 2. 1 to 2, in between 1 to 2, that means you can choose on point between 1 and 2, that means you can take 3 by 2. So, 3 by 2 if I am taking here, and that will give you what? That is 27 by 8, and 1 by 2 will be there, 3 by 2, sorry, that is 3 by 2, 3 by 2. So, that is what? That is your 8, 27 and that is 12. Anyhow, we are getting some positive value, and that positive value means we have to choose this one. So, that means x cube minus x and dx. So, look here, this function I have made some sub intervals from minus 1 to 0, then I made 0 to 1 and from 1 to 2, and then after I choose the functions from this one, from the definition of mod function, that is x cube. Wherever it is negative, I put the negative function, and wherever it is positive, I have get the positive function. Now, this is the simple integration that you know very well. Simple integration is what? That you can write x power 4 minus x square, x power 4 by 4 minus x square by 2, and put the limit over it, that is 0 and minus 1. Here we have minus sign because this plus minus, and again we do the integration over this, that is x power 4 by 4 minus x square by 2, the power, the limit is 1 and 0, and then plus x power 4 by 4 minus x square by 2, and the limit is 2 and 1. So, this is equals to, that is power 0, that means first term is over, that is first term will be 0, and second term will be minus of what? Minus of, that is minus 1 power whole 4, that means 1 by 4 you will get here, that is again minus 1 by 2, that is minus whole square, that is minus of 1 by 2. Here what you will get? It is minus, and this is 1 you put here, that means 1 by 4 and minus 1 by 2, 1 by 4 minus 1 by 2, and the rest part will be 0. So, no need to write, close it. Here you will get, that is 2 power 4, 2 power 4 means that is 16 by 4 minus 4 by 2, this is in one bracket, and minus 1 by 2, 1 by, not 1 by 2, that is 1 by 4 and minus 1 by 2. minus 1 by 2, and here I close the bracket. So, finally, this is minus, here what you will get, that is 4, here is 1 and minus 2 is here, that means minus, here again you will get 4 and that is what you will get 1 minus 2, okay, and here that is how much, 4 minus 2, that is 4 minus that is 2 minus, and that is 4 1 minus 2, okay. This will give you minus, that is minus of 1 by 4, that is plus 1 by 4. Here again that is minus 1 by 4 and it will make as 1 by plus 1 by 4, and here that is plus 2 minus, that is minus 1 by 4 plus 1 by 4, and finally you get the result 1 by 4, 1 by 4, 1 by 4, that is 3 by 4 plus 2, and that will make you 11 by 4. This is the answer of this question. So, what I did? I make the sub intervals, okay. Then I use the definition of mod functions. So, this one is one type of problem, and all such problems you can use P2 property of definite integrations, okay. So, this is one time. Dear students, I will try to give you all types of problem depends upon this property, okay. This is the first type, depends upon P2. Now, I go to some another type which will depend on some other property, okay. Let us move to the next question. Now, look at this problem. I have, that is I equal to integration from 0 to pi by 2 log sin x dx, okay. So, this take this is as 1. Now, which property we can apply over here? Do you remember that property, that is integration of from 0 to a f of x dx is equals to integration of 0 to a f of a minus x dx, that is property, I think it is P4. This property I will apply over this question because it is 0 to pi by 2, 0 to a, okay. Now, applying this property P4, what you will get? You will get 0 to pi by 2 log sin pi by 2 minus x dx. This is equals to 0 to pi by 2 log sin become now sin pi by 2 minus theta, that is cos theta, cos x dx, keep this is as 2. So, this is also I. So, if we add or adding 1 or 2, adding 1 and 2, we get what you will get, that is I, that means you will get 2I here, and this is equal to integration of 0 to pi by 2 log of sin x dx plus integration of 0 to pi by 2 log of cos x dx. Now, we all know the property of logarithm, that is log mn equal to log m plus log n. That property I use here, that is log m plus log n. So, that means if we have log sin x and log cos x, so I can apply this property over here. So, this one can be written as 0 to pi by 2 log of sin x cos x and dx. Now, it seems to be on formula of sin 2x. We know that sin 2x is what? Sin 2x is 2 sin x cos x, okay, but 2 is missing here. So, I want to get some 2 here, so that I can write this thing as sin 2x. So, what to do for it? I simply add over this integration 0 to pi by 2 log of 2 dx and subtract the same thing 0 to pi by 2 log of 2 dx. Now again by using our log property, I can bring these 2 with the product of this one. So that means you will have, that means we have this 2I is equals to some integration of 0 to pi by 2. This is log of 2 sin x cos x minus this log 2 is constant. So I can take out of this integration sign. So that means log 2 integration over, that is 0 to pi by 2 dx. Now here what we can write here, that is 0 to pi by 2, that is 0 to pi by 2 log of sin 2x minus log 2 integration of 0 to pi by 2 dx. Okay. So now look here, this integration is simple one, only you will get the integration of dx, that means x you will get here, but this one we have to simplify. So let us assume this as I1. So this is I1 minus log 2 and this is this integration is x. So I put here, that means pi by 2 0, this will give you I1 minus, that is pi by 2, so I write pi by 2 log 2 here, keep this is as number 3. Now from this 3 I use this I1 as, that is 0 to integration of 0 to pi by 2 log sin 2x. Now I simplify this one. So let us take this one I1. Now this I1 is what? Our I1 equal to integration of 0 to pi by 2 log sin 2x dx. So putting this t equal to 2x, that means your dt will be 2 times of dx. So this implies 1 by dt equal to dx. When your x equals to 0, you put 0 here, that implies t equal to 0, and when your x equal to pi by 2, that then t equal to what? That is pi by 2, 2, that is 2 to cancel, that means t equal to pi. Therefore your I1 become, that is 0 means 0 and this pi by 2 become pi now, and log of sin t dt, and dt is what? 1 by 2 times of log sin t dt. Okay. So look here, we have now this 0 to pi log sin t dt. Now as we know, our property P0 says that if we change the variable of any integrand in a definite integration, then the value does not change. That means if I change this t with x and this dt as dx, then there will be no change in the value. So that means we can apply P0 and we can write this I1 as 1 by 2 0 to pi log sin x dx by using P0 property. Okay. So again now look here, we have 0 to pi log sin x dx. Now I deal with this one. So this one, suppose your fx equal to log of sin x, that is f of pi minus x is what? To log sin, that is pi minus x, and that is equal to log sin pi minus x sin, that is simply sin x, and that is nothing else but that is f of x, that is f of pi minus x is nothing f of x. Now we have the property, remember that property, that is P5, property number P5. What that say? 0 to 2a f of x dx is equals to 0 to 2a f 0 to a f of x dx plus 0 to a, that is f of 2a minus x dx, and that if this one is f of x, then this one is 2 of x, then that is equal to 0 2 times of 0 to a f of x dx, that is P5, property P5 says this one. So we can see that f of pi minus x will give you the f of x. So that means your this one pi, we can write it as 2 times of pi by 2, that means 0 to 2 pi by 2 times of pi by 2, and that property satisfies, this property satisfies over this. So that means this one we can write as I1, your I1 is equals to 1 by 2, and this satisfy that one. So that this full one we can apply property P5 and we can write this is as 2 times of 0 to this pi now become pi by 2, because I have written 2 into pi by 2. So that is pi by 2 log of sin x dx. These two will cancel out. So that is equal to 0 to pi by 2 log of sin x and dx. Now look here, this is I, your equation 1, this is I means 0 to pi by 2 log sin x dx, and that is exactly the same thing as I, that means your I1 and your I is same. So that means this one I can write at I. So now in equation 3, come to the equation 3. Our equation 3 was what? That is 2I is equals to I1 minus pi 2 log 2. So that means this I we can replace by simply I minus pi by 2 log 2. So this is equals to this I bring to the left hand side, and 2I minus I, that is I equal to minus pi by 2 log 2. That is the answer of this question. Here in this question I have applied P4 property first, then P0 property second, and then third P5 property. 3 property I applied over the same question, and I got the result as I equal to minus pi by 2 log 2. Also I applied the log property. So dear students, log property is important here, and in one question you may use 2-3 properties at a time. Okay. Now let's move to the next one. Now look at these 2 problems. In the first one we have integration minus pi by 2 to pi by 2 sin power 4x dx, and in the second problem you have minus pi by 4 to pi by 4 sin cube sin power 4x. These 2 problems are as per property P7. In P7, that is property P7 says, that is integration of minus a to a f of x dx is equals to 2 times of some 0 to a f of 0 to a f of x dx if f of x is an even function, otherwise it will be 0 if f of x is an odd function. So this is our property P7. So we can apply P7 over this. Let us see in the first question, f of x, here your f of x is equals to sin power 4x. Now I check for f of minus of x, and that is equals to sin power 4 of minus of x, and sin minus of theta is minus of sin theta, that means this is minus sin x whole power 4, and that will give you the sin power 4x, and that is equal to f of x. That means f of minus of x is equals to f of x. So, that means f of minus of x equal to f of x, that shows that this is even function. So, it is even function, that means we have to use this property. That means therefore, minus of minus pi by 2 to pi by 2 sin power 4 x dx can be written as 0 to pi by 2 sin power 4x dx 2 times of 0 to pi by 2 sin power 4x dx. And now sin power 4x, what we can write, that is sin square x over sin square x, that means that is 2 times of 0 to pi by 2 sin power 4 can be written as 1 minus cos 2x by 2 the whole square and dx, that is equal to 2 times of integration 0 to pi by 2. Here I can apply a minus b the whole square form, that is a square minus 2 cos 2x and plus cos square 2x full divided by, now it is 4. So, I bring this 4 out of this integration sign. So, that will give you 1 by 2 0 to pi by 2, and we have 1 minus 2 cos 2x plus cos square 2x dx. Now, again you can change this cos square 2x. So, cos square 2x we can write as 1 plus cos 4x by 2. So, that means you can write it as 1 by 2 integration of 0 to pi by 2 1 minus 2 cos 2x plus 1 plus cos 4x by 2. Okay. Now, here we need simplification, that 2 plus 1, that will give you 3. So, I write here, that is integration of 1 by 2 times of integration 0 to pi by 2, that is 2 plus 1, that is 3, okay, and that is minus 2 times of cos 2x minus 2 times of cos 2x and cos 4x, okay, and divided by 2. That 2 again you can take out, that means 1 by 4 integration of 0 to pi by 2, and this is 3 minus 2 cos 2x plus cos 4x. Now, you can simply do the integration over here and put the limit, you will get the final answer. So, this way we can find out the solution of the even functions. Here I applied the property P7. Now, look here at this problem. Again same thing, here f of x equal to sin power 4x and x cube will be here. You will have x cube here also, that means I put that is minus of x cube, and that minus of x cube, that is equal to minus of x cube, that is minus of x cube sin, and this will plus this sin power 4 minus of x, it will be sin power 4 plus of x. So, now look here, that is minus of x, and that is nothing minus f of x. So, f minus of x equal to minus of f x, that shows that this is a odd function, and when it is a odd function, so no need to do any integration over this one, it will simply give you 0. Okay. So, that means you will write the answer even directly by saying that this is a odd function, because of this f of x is equals to minus of f of x. So, this will give us a odd function, hence the answer will be 0, you can write directly. Okay, dear students, I think you have enjoyed today's lesson, and we discussed various properties and some problems of this definite integration. Now, we go to the next lesson and see the applications of these definite integrations, and we can find the area under the curve. Okay, let us see you in the next class.